has a higher viscosity, gets thicker. Whenever we have a material that increases viscosity with the lower temperatures, that material is usually known as being temperature sensitive. Means with colder temperatures it's going to thicken up. As it's warmed up, it's going to thin down. Remember, with polyureas, we do not use solvents. With standard epoxies, urethanes, enamels, if we need to lower the viscosity of that coating, we put in a little bit of xylene or MEK to help thin it down. With our polyureas, we use heat, we use temperature to decrease that viscosity, to make it flow more easily, make it mix better. Then we have our material flow volume, and we want to have greater than the capacity of our spray gun setup. If our gun is set up with more flow than our proportioner is, we're going to see very low dynamic pressures. We may start off at 3,500 psi, we may drop down to 1,000 psi. And if we're pulling the trigger and we have those low pressures, then when we release the trigger, what you will hear when you release the trigger, your transfer pump should stop pumping. If you release the trigger and your transfer pump is still pumping and your proportioner is still pumping, that's a sign that your gun is, the output capacity of that gun is greater than your proportioner is set up for. So you need to decrease the size of the mix chamber and tilt inside of that gun. The transfer pumps, the drum pump output must exceed the total equipment output. So the rule of thumb, the drum output or the drum pump should be 2 times the volume of the proportioner gun combination. So if we can't get enough material out of the drum to feed our proportioner and our spray gun, we're going to go into what's known as a cavitation starvation mode.